Okay, we got one more example I wanted to do in chapter 5. We got a wagon. Okay, we'll call this M2 because it's going to be connected to another wagon here, M1. And I'm going to pull here with an applied force F, or F sub A for applied force, and I'm pulling in an angle of 35 degrees. Let's say that M1 is going to be 24.6 kilograms. Let's say that M2 is going to be 33.6 kilograms. Let's say that my applied force is going to be 17.6 newtons. So I want to know what is the acceleration of these wagons as I'm pulling. Okay, so we have a wagon right here, got some stuff in it, has a certain mass. Okay, I'm pulling on it like that, but it's got a trailer attached to it. So another wagon with like a rope or something connected to the second one. So that's what I'm after. I'm trying to figure out what is this, okay? And so what we do is free body diagram. Okay, there's going to be a tension in here between these two, okay? And I can look at it and say free body diagram for mass 1. We got that tension pulling forward. We got M1G down. We have normal 1 up. For mass 2, got my applied force at an angle. I've got the normal Fn2. I've got M2G. And I've got tension. Okay, so we know it's accelerating this way. Okay, so for the mass 1, we can say tension equals M1A. For mass 2, okay, Fa cosine theta minus tension equals M2A. We know that this we know that the weight of mass 1 exactly balances the normal here. We know that the normal Fn2 is balanced by Fa sine theta plus M2G. So this gives us the conditions. I said, well, I got 2 equations, 2 unknowns I need to solve. Well, this is easy. T equals this, so I can plug that in right there for T. So we have Fa cosine theta, okay, that's minus the tension, so that's going to be minus M1A equals M2A. And so Fa cosine theta equals M1A plus M2A. So A equals Fa cosine theta divided by M1 plus M2. Well, I have all these terms, so I just plug in the terms. So that would say, therefore, that the acceleration is going to be equal to 14.8 newtons times cosine of 35 degrees, okay, divided by 24.6 kilograms plus 33.6 kilograms. So the acceleration is 0.254 meter per second squared. Okay, you could have written that, if you don't like the decimals, you could have written that 25.4 centimeter per second squared. And I'd be fine with that. Okay. In fact, if you really wanted to, you could have written that as 10 inches per second squared. And that would also be correct if you really wanted to do unit conversions. And so, again, I don't really care as long as your answer is correct in the units that you pick. And but you have to keep track of the units. If you mess up on the units, the answer is wrong. But be consistent, and I'm perfectly happy.